figure. Hi Year 7, Mr. Wilson here. I've got another experiment with some atoms, with some elements, some compounds and some mixtures doing a chemical reaction. First thing I'm going to do is I'm going to take some magnesium, which is an element, and I'm going to weigh it. I've got 0.3 grams of magnesium. I've written that down, and I'm now going to take this magnesium and I'm going to put it in a very hot Bunsen flame, to make a chemical reaction start. And I'm going to explain more about this in a bit, but I have to get this going because it takes some time. So I'm going to put that there, and because it's very hot, I'm going to carefully put the lid on, and we'll come back to that in just a moment. Now, magnesium is a metal element. It's made of just one type of atom. It's over on the left-hand side of the periodic table, which means it's a metal. I'm reacting it with oxygen, which is a non-metal element. It's on the right-hand side of the periodic table. Oxygen is a gas in the air around us. We also know that oxygen is what we breathe in to use in respiration. I'm going to take some magnesium now. I'm going to get it burning, and I'm going to show you what it looks like when magnesium burns. Look at that. I'm going to look away because it's so bright. That is magnesium, very hot, reacting with oxygen in the air and giving off lots and lots of energy in a chemical reaction. What I've made is something called magnesium oxide. It's a white powder. It's a compound of magnesium atoms and oxygen atoms. They're chemically joined. Two different types of atom. Chemically joined is a compound. Now what we're going to test is we're going to see how much oxygen reacts with the magnesium. That's why I very carefully measured 0.3 grams of magnesium, put it in my crucible and started heating it. When it gets very, very hot, it will react with the oxygen and form magnesium oxide. And then I can weigh the magnesium oxide again and see what mass I've got. We know that the mass of magnesium and the mass of oxygen that react together will make the mass of magnesium oxide. All of the atoms come together to make the product. So we should be able to see how much oxygen has reacted with the magnesium. This should be very hot now, so I'm going to check it, see if it will start reacting. Oh, I think it might be about to start. I can see it starting to burn in there. There we go. I don't want to let any get out, so when it starts burning, I'm going to put the lid on, and I'm going to do the same again. Let it start burning, put the lid on, because I want to get the oxygen in, but I don't want any of my compound to come out as it's burning. All of that smoke is my compound magnesium oxide escaping. Let's give it a little bit longer. Yeah, that's finished burning now, I think. I think that's all of my magnesium as magnesium oxide. So I'm going to take the heat away to stop it from burning. Next, I'm going to let it cool down for about 30 seconds, and then I'm going to take the lid off, put it back on my balance, and see what is the mass of magnesium oxide that I've made. See how it's going. It's still very hot. Okay, that looks good. So again, this is super, super hot. It's been a really hot flame. I'm going to bring this over here, put it on my balance. I have 0.3 grams of magnesium. I've now got 0.4 grams of magnesium oxide. Here we go, I'll show you my equation. Magnesium plus oxygen, those are the reactants. There's my arrow to show the chemical reaction makes the product magnesium oxide. I had 0.3 grams of magnesium. I've got 0.4 grams of magnesium oxide, which means I must have 0.1 grams of oxygen. There we can see that 0.3 plus 0.1 will make 0.4. That shows something called the conservation of mass, that the mass of the products is always equal to the combined mass of the reactants. And that is a very good illustration of some elements and some compounds.